polygons. So a polygon is, it's a shape with many sides, which is kind of a lot of shapes really. And there are two types of polygons. So a regular polygon has all sides are the same side and all angles are the same side. So let's have a look at an example of that. So this, pretending it's drawn accurately, is a regular polygon. So we know it has all sides are the same side and all angles are the same side. So all of these are the same length and all of these are the same side. So if it says it's regular, that's what you need to know. So this here, that makes that an equilateral triangle. Let's have a look at another example of a regular polygon. So this is the classic square. So we know for a shape to be a square, all these lines are the same size, and we know that these angles here are all 90 degrees right angles. So we have all the sides are the same side, all the angles are the same size, and it's a shape with many sides. So an equilateral triangle and a square are both examples of regular polygons. What is an irregular polygon? So that, for example, might look something like that. So as you can see, it is a shape with many sides, but these sides are all different lengths and the angles on the inside are all different sizes. Okay, so let's go back to a bit of information about regular polygons. We prefer regular normally come up, but it's good to know the differences. So, for a regular polygon, the number of lines of symmetry is equal to the number of order of rotation and it's equal to the number of sides. So let's have a look at that on our equilateral triangle. So as we can see, a line of symmetry, we're going to have one here, because if you fold it in half it should fit nicely. Going to have one here, and we're also going to have one down here. So that means we have 3 lines of symmetry. That means our order of rotation is 3, so you can do 3 different rotations and end up with exactly the same shape. And what are our number of sides? 1, 2, 3, 3. So from just knowing the number of sides, so for my square, I know there are 4 sides, 1, 2, 3, 4, which means I know there are 4 lines of symmetry, which is 1, 2, 3, 4. And I also know that the order of rotation is also 4. So that's a useful bit of information. So let's go and go on to looking at some theory about the angles before going on to some questions. So the questions you get on polygons always normally involve the angles. So we're going to look at key points that we need to know to be able to answer the questions. Okay, so these here are 2 facts that work for all polygons. So all polygons means you've got the regular and the irregular. It works for both. So let's look at point number 1. The sum of the exterior angles is 360. Okay, so let me just draw one that we know a lot about. So let's say this is our equilateral triangle. What are the exterior angles? So first of all, what are the interior angles? These are the ones in the inside. So the exterior angles are, I'm going to show them in red, this one here, and this one here. So these are the exterior angles, and the sum of those is 360. If we move on to the second point, we've got the sum of the interior angles is n minus 2 multiplied by 180. So it's very important to know that n is the number of sides, so I'll put that in here. So let's test that with our equilateral triangle. So sum of interior angles is n minus 2 times multiplied by 180 degrees. So for a triangle, we know that we have 1, 2, 3 sides. So this is regular or irregular, this works for all, so it doesn't have to be an equilateral triangle, just triangle. So 3 minus 2, because n is 3 sides multiplied by 180 degrees. So 3 minus 2 is 1, multiplied by 180 degrees gives me 180 degrees. And that is the sum of interior angles. And we already know that fact. We know that all the angles in a triangle add up to 180 degrees. So that seems to work. Let's see what would happen if we did that with a square. So the sum of the interior angles of the square is going to look like this. The sum of the interior angles is, because square is a regular polygon, this also counts in all polygons. So we have the formula is n minus 2 multiplied by 180 degrees. Now we know n, how many sides does a square have? 1, 2, 3, 4. So we know n is 4, so 4 take away 2 times 180 degrees. So 4 subtract 2 is 2 multiplied by 180 degrees, which is 360 degrees. So we've got the sum of interior angles of a square is 360 degrees, which we already knew, maybe just from knowing it, or should know. But we also know these are all right angles, so these are all 90 degrees. 90 plus 90 plus 90 plus 90 is 360. So that kind of confirms what we know. So let's look at some more information specifically about regular polygons, not just for all polygons. Okay, so now we've got the extra circle, which is just for regular polygons. So you've got the bit just for regular polygons, and then you've got this bit for all of them. Let's have a look at what it's told us. So it says the exterior angle is 360 divided by n. So let's just have a look at an example. So here is a regular pentagon, which means all of these lines are the same size and all of the interior angles are, even if it's not drawn accurately. So let's add on our exterior angles. So these are our interiors and these are our exteriors. So these are our exterior angles, and it says exterior angle equals 360 divided by n. So 360, so n is the number of sides. We have 1, 2, 3, 4, 5. 360 divided by 5. So that tells us that it's 72 degrees. So we know each of these exterior angles is 72 degrees. This one is 72 degrees, this one is 72 degrees, this one is 72 degrees, this one is 72 degrees. So that's simple enough. Let's look at the other point. Interior angle is 180 degrees minus the exterior angle. So let's see how we know that. Let's look at this section. We've already got that this is 72 degrees and that's the exterior. So here we have the interior, and we know that angles on a straight line add up to 180. So if we were going to write that out in a formula, we would have the int plus the exterior, these two angles, equal 180 degrees. So the interior angle, the int, is 180 degrees. Take this over, there's plus on that side, so it becomes minus the exterior angle. So that's how we got that formula there. We do know how to calculate the exterior angle, so we can do that in one step and put the exterior angle is this, we can substitute that in there. Okay, let's have a go at some exam questions. So this is our exam question number 1, and it says find the side of the exterior angle of a regular pentagon, and it's giving you the drawing, and then that's the exterior angle. So the first thing we know is regular, so we can use those outside equations. We know that from what we just looked at, the exterior angle, but it has to be of a regular shape, hence it writes it there, is 360 degrees divided by n. Okay, so you may or may not know that a pentagon has 5 sides, but you can add them up. So 1, 2, 3, 4, 5 sides. So n is equal to 5. So we know the exterior angle of a regular polygon, 360 divided by 5. And that is equal to 72. So that's actually the example we just did. So we found that this is 72 because it's an exterior angle, and that's all you need to do. So all you need to know for that question is remember the formula. And this is why this formula works, because if you add all of these up, but because it's regular, you know they're all the same size. So if I say this is B, 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 I've got B, 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 B. So I've got 5B, and we know for all polygons, regular or irregular, they sum to 360 degrees. So we know that one of those angles, B, is 360 degrees. Take the 5 over, in this case we divide by 5. But we could replace this 5 with n, and that's how we get the formula of if it's regular, because these are the same size. If it's irregular, these b's aren't all the same and we can't use this formula. But that's just showing you how it works, and that's just the first exam question. Okay, so this question says the size of each exterior angle of a regular polygon, so first thing to note is it's regular, so all the interior angles and lengths are the same, is 40 degrees. How many sides does it have? So in this question, I've been given exterior angles is 40 degrees. How many sides does it have? So we know that an exterior angle from our equation for a regular polygon is 360 divided by the number of sides. So n is what we're looking for. Do we know what the exterior angle is? It says the size of each exterior angle of a regular polygon is 40 degrees. We do. So let's substitute 40 degrees equals 360 divided by n. Now let's rearrange and solve to find n. So n is divided on this side, so if I bring it the other side of the equals, it becomes multiply. So I'm going to have 40 degrees multiplied by n. You don't have to write multiply, because there's a letter, you can if you want to. So n is, so it's 360 degrees divided by 40, and that gives me 9. And I think that's called a nonagon, but I'm not too sure. I should probably check that. Okay, so the next question, the size of each interior angle of a regular polygon, so important to note is regular, they don't just say that for fun, is 156 degrees. Work out the number of sides it has. So, as we know from the formulas for regular ones, an interior angle is equal to 180 degrees minus the exterior angle, and we showed how that worked before, because they're on a straight line. So let's say this is your interior, this is your exterior. If you sum them, they equal 180, and then you take the exterior over this side of the equal sign, it becomes minus. That's how. So what information have we been given? We've been given the interior angle is 156. So let's use that. So let's substitute that in. 156 is 180 degrees minus the exterior angle. Okay, so let's rearrange and solve. Basically, we know the exterior angle is 180 degrees. Take away 156 because we bring the exterior over there and the 156 over the other side. And that gives me that the exterior angle is 24 degrees. So it's basically saying this is about 24 degrees. Well, it's 24 degrees and this is 156 degrees. Obviously that was not drawn to scale. We're looking for the number of sides, so now there's only one other equation we know, and that is the exterior angle equals 360 degrees divided by n, which is the number of sides, which is what we're looking for. So now we've worked this out, we can substitute it in. So we have 24 degrees is equal to 360 degrees divided by n. So now we're at the same place as we were in the last question, so rearrange and solve. So we can bring n up there and multiply up, so I'll do that in steps. So n is divided on this side, so you bring it up, it becomes multiply, and then n equals, you want the 24 to go away, it's multiply on that side so it becomes divide. 360 degrees divided by 24 degrees, which tells me that n is 15. So it has 15 sides, this regular polygon. So here is the diagram, which is really poorly drawn, and I am sorry about that. These are supposed to be regular pentagons, so all these lines are actually the same size, and all these interior angles are the same, okay? So, a square is attached to 4 regular pentagons, find x. So this is my square, and these are my 4 regular pentagons. So important to note, regular. So find x. First of all, what do we know we can actually find? So we do know one equation, which is the exterior angles. One of them is 360 divided by n. So if I'm looking at a pentagon, I have one of the exterior angles is 360 degrees divided by 1, 2, 3, 4, 5 sides divided by 5. And that gives me an answer of 72 degrees. So we've done that previously. So therefore we know this is 72 degrees. This is, and then it's the same for all of these different shapes. So if we know this is 72 degrees, we can work out the interior angles. So all the interior angles are the same in all of these shapes. We also know these. So let's call this y. So we know y, so we know these two angles added together form a straight line. So we know that y plus 72 degrees is 180 degrees. So that y equals, if we rearrange this, 180 degrees, take the 72 over, it becomes subtract 72. That tells me that y is 108 degrees. So I'm going to rename y, I'm going to call that what it is, 108 degrees. I also know that that is 108 degrees. I also know that this is 108 degrees. I know that this is 108 degrees. I know that this is 108 degrees. All of these are 108 degrees, basically. I'm not going to write them all out because that is going to take me a while. Okay, so if I blow up this bit here, I have the right angle from the square, and then I have those two lines here. Here I have x, here I have 108 degrees, and here I have 108 degrees. So I've just basically got a magnifying glass over that section there. So what do we know? Around a circle here, all the angles sum, so add together to give 360 degrees. So we know 3 of the angles, we're just looking for 1. So that would look like this. So 360 degrees equals all of these 4 angles added together. So here we have the 90 degrees, plus this one, 108 degrees, plus this one, another 108 degrees, plus x. So now, simple enough, we just need to rearrange to find x. We have all the info we need. So x is equal to, and if you work that out, that means x equals 54 degrees. Okay, so my tips for these types of questions is, even though you can't find x immediately, instead of just focusing on what the one specific angle they're asking for, do everything you know how to do. So in all of our exam questions, we use this formula here. They were all regular, so they're usually regular polygons, and we use the fact that one of the exterior angles is 360 degrees divided by n. So just do that. You're going to probably get a mark for it anyway. Write it down on the diagram, find everything else you can do, and then once you think you've got all the information you can, then find the specific angle they want. So sometimes it's not just a one-step thing. Try and work out everything else, put it on the diagram, and then see where you're at.